Hello guys, welcome back to my channel and welcome to the series of probability. Okay, so now let me do a small recap of what we learned in last class. Okay, so we know we check the definition, what is the conditional probability is the formula, how to solve the solving the problem, and what's the states that probability of probability of a given B already occurred that we can say from this, and this is the intersection B and P of B, and we know that we can't find the proof of this, but we intuitively prove that, and we also proved intuitively in our last class. Okay, so as we promised, today we are going to solve the numerical problem and one another method that's called tree method to solve the problem. So okay, let's directly jump to the numeric. Okay, I think the screen is visible to you. Okay, and let me do some small adjustment for you. Just 2 seconds. Okay, I think it's visible to you all. So let's start with this problem. Hmm. What's the problem? Consider the family has 2 children. Okay, so these are two different questions. Okay, let me change the color here. It is this 2 children, and we are. I think we are going remove just guys. Uh, mm, okay, yeah, I got it. Find it. If family has 2 children, okay, and we are interested in the children's gender. Our sample space. So this is the sample space. Okay. Our sample space is GGGBBBG. Okay. Let's assume all four possible outcomes are equally likely. Yeah, that's also true. Okay. Now let's solve the first problem. So what's the problem is, what is the probability that both children are girl, given that first child is girl? So both children are girl means GG. Okay, given that no. I think I write it wrong way. Hmm. What they asked the probability that both children are girls. Both children are girls, given that first child is girl. So what's the sample space for this? First child is girl. We can have two GG and GB. Now we are using here formula to solve this. P of GG intersection GGGB upon P of GGGB. I think you'll not find good here, right? P of GG intersection GG upon GB. So as here mentioned that possible all outcomes are equal likely. So the number of elements in A intersection B 1 upon number of elements here 2. So for the first question answer is 1 by 2. Yeah, let's go for the second one. What's asked? We asked the father, do you have at least one daughter? Do you have at least one daughter? He responded, yes. Given this extra information, what is the probability that both children are girls? Or in other words, let's start from here. probability that both children are girls, both children are girls, given that at least one of them is girl, at least one of them is girl, means GG, GB, BG. Again, the same thing, the intersection of this one, number of element in B, 1 by 3. Okay, this is a very easy example. Okay, now let's move to the next one. Okay, I think I have to remove this. Okay, now let's go for this example. Suppose we flip a fair coin. So when we are flipping, the number of outcomes are 8, which is 2 power 3, 3 times, as we mentioned. Let F, A stands for, what A stands for? Event that the first two coins both head. So what's A means event. A is event, and the event is first two coins are both head. So what is the probability from total 8 cases? How many cases where the first two coins are both head? So HHT and HHH. These are the two possibility here. So what we can write 2 by 8, 1 by 4. Okay. Now let's go for the B. B stands that the even that third coin is different from the second coin. Third, not equal to second. So which are the cases from 8? So second and third are not same. So HT, TH, here H, T, H, TH, H, H, T. So as you can see, the second and third are not same. In total, we have 4 cases. Okay, I think I repeat one case here. Why it's not it is? Oh yeah, I am forgetting. H H H T T H here. T, yeah, right here T H T. So total we have 4 cases out of 8. 4 by 8 equal to 1 by 2. This is P of A, 2 by 8. P of B, 4 by 8. Okay. Now what's the P of A given B? So P of A intersection B divide P of B. What's the P of A intersection B? P of A intersection B is first two coins are both hit. So you can write from here like direct do the intersection. Then this HHT is the only one which is common here. So HHT P of HHT upon P of B. What is the possible probability of you getting HHT? That's 1 by 8. What is the probability of getting P of B? 1 by 2. Just do the simplification. You'll get 1 by 4 is the answer. This is very easy example, as I told you also. Now, let's move to the next thing, which is a tree method. Okay. So, what is tree method or tree diagram? So tree diagram is for the conditional probability, as here also wrote it's for the conditional probability. So how it will helpful to solve the problem. So okay, let's say we have a tree diagram for coin toss. What's the tree diagram? Tree diagram for coin toss is if we are tossing a single coin here, thus we are talking about single coin, then the outcome may be head or outcome may be tail. There are two types of outcome can be possible, head or tail, and the probability are zero point 0.5, zero point 0.5. Like the same case, if we are tossing a coin twice, then we can divide this further, we can divide this further. This is the very best method to solve a problem. So if you don't get it, just leave it. I'll with the example, I'll tell you the best way. to understand this question. Okay, so this is the example which I am talking about. Okay, this is the best example, but just you have to be a little conscious when I was solving. So be focused. Okay, so you are off to soccer. Okay, and love being the goalkeeper. You love being the goalkeeper, but that depends who is coach today. Okay, with coach Sam, the probability of being goalkeeper is zero point 0.5, and with coach Alex, the probability of being goalkeeper is zero point 0.3, and probability of Sam being a coach. The first thing here mentioned who is the coach. So if coach is Sam, and what's the probability for Sam being a coach? And what's the probability for Alex being the coach? There are only two coach possible. Either the coach is Sam or Alex. So the probability of Sam being a coach is zero point 0.6, then the probability of being Alex is by default zero point 0.4. Okay, this is the same thing like if we toss the coin. But if it's not a fair coin, then the probability of being head is zero point 0.6 given, then you can say that the probability of being tail is zero point 0.4. Okay. Now we are going in further. So with coach Sam, if Sam is coach, then probability of being a goalkeeper, okay, is zero point 0.5. So what's the probability for under same coaching not being a goalkeeper? 1 minus zero point 0.5 and 5. Same for the Alex. Being a goalkeeper is zero point 0.3, and the reverse thing is zero point 0.7. Not goalkeeper, not goalkeeper. With coach Alex, the probability of being okay, this okay. Now, what's the probability that you'll be a goalkeeper today? What is the probability you'll be goalkeeper today? So from here we can say that we have a two case where we can be a goalkeeper. One case is when Sam is coaching, and one case is for Alex. So just do the multiplication, because what's the stats that this stats that when Sam is coach and you are become a goalkeeper, or when Alex is a coach and the probability of you become a goalkeeper. This is the answer. Now you might thinking that what this all states that. So this is the probability of Sam. This is the probability of Alex. This branch represent probability of being a coach given Sam as a coach, probability of being a goalkeeper or not goalkeeper being and the same as a coach. Here, this represent probability of being a goalkeeper given Alex is a coach, and for this probability of being a non-goalkeeper given Alex is the coach. And if you are talking about this circle, then just do the multiplication. And okay, in future we are also going. Okay, yeah, let me tell you here only what's the multiplication rule. There is one multiplication rule which is P of A intersection B is same as P of A into P of BA equal to P of B into P of AB. This you can get by the conditional probability only. This is very easy to understand by yourself only. Okay, so this we can write as P of LX intersection not goalkeeper, and this circle represent P of LX intersection goalkeeper. Like this, you can check here LX not LX. Here we have to write it as the same intersection not goalkeeper, and here the same intersection goalkeeper. Okay, so this is the very understanding thing. And now if you want to check how this is come mathematically, then we are going to see it in future, the called as the total probability. In total probability, we are going to see this, but as of now, you can check. So for this problem, we are using a tree diagram to solve this. Okay. Now for the same, we are solving this question also. Here also we have to make a tree. On a Sunday evening, 50% means point 0.5 watching movie. Okay. 30% means point 0.3 watching cricket match, and the last point 0.2 watching comedy show. Okay. Out of these people, there are two possibility. What two? Skipping the ads means one can skip ad, one cannot skip ad. Okay, while watching the movie. For here also skipping ad and not skipping ad, and for this also skipping ad, and another the last is not skipping ad. Now what we are going to do with this? So what's this probability? This is given. Skipping add is zero point 0.2, so the remaining is zero point 0.8. This is 0.25, remaining is 0.75. Here 0.15, so the remaining is 0.85. Okay. Now, what we want to find? We want to find P of from this notation. Watch cricket match and seeing it. So if you know how we can represent all this branch, then you directly get the solution. Okay, let me denote all this by a notation. How we can represent it by a different notation. So what's this branch? Is for P of M. This is for P of cricket match, and this is for probability of comedy show. Okay. Now let's change the color, and they're talking about this. This line is for skipping ads given that watching cricket match. The same. Skip not skipping it given that watching no not cricket match movie. Okay. Here he is watching a movie, but we here watched him a cricket match. For this skipping ads given watching cricket match, not skipping ads given watching cricket match. For this branch, it is skipping ads watching comedy show, and for this line, not skipping ads watching given watching comedy show. Okay. And if you want to denote this circle, we want to find this cricket watch and SA means skipping it. So what's the representation of this for this circle? So for this, we can write, as I told you in the previous example that I'll explain in the total probability, what's the multiplication of P of cricket watch into P of SA SCM. SA given CM means skipping X given CM. Multiplication rule, it is the same thing. P of C1 intersection SA, and we have this value. CM is zero point 0.3 and SA given CM is 0.25. So the answer is 0.75. This is the very easy example. You just have to know what this branch states like, means this branch represent which probability, and based on this you can answer this type of question. Okay. Now let's do a quick revision of what of like this. So what's here x represent? What is the value of x represent, y represent, z represent, and c1 represent? Okay, you can comment down your answer here and just check it whether you got the same answer. So as we know that x represent probability of A1, y represent probability of B2 given A1. Okay, so this is for x, this is for y. Okay, C represent probability of C1 given B2 intersection A1. Yeah, so this is for Z. What's this circle represent? Circle represent event. Circle does not represent the probability, but circle represent event. And what the circle representing? Circle representing multiplication of all these things means A1 intersection B2 intersection C1. That's what you are getting. Okay. So this is all about the today's lecture. So if you like this video, then do like and share with your friends. Okay, let me make it. Okay. Share with your friends and just comment down what you think about the lectures here. Okay, thank you guys.